In this short video, we are going to see some cryptographic principles and apply them to the Nexus repository, how exactly it is used in Nexus repository. So let's start. So asymmetric cryptography. So basically this is a key pair. So we have a public key and a private key. So anything which is encrypted with the public key can be decrypted using the private key. And if it is encrypted using a private key, it can be decrypted using a public key. Okay, so they are mathematically related. And what happens is that the public key is shared across. Everybody has access to the public key, but the private key is kept as a secret. Nobody has access to the private key. So let's see with an example. So there is a message. The message is encrypted with the help of public key. This is the ciphertext, and the ciphertext can be decrypted using the private key of Alice. So the same key pair, Alice's key pair, and it can be decrypted using the private key, and we get the original message. So this is a asymmetric cryptography where public and private keys are used. In symmetric cryptography, we have a shared secret. So the same key or the same secret is used both for encryption. This message gets encrypted here, and for decryption. So this is much faster than public key cryptography, but this is little more insecure because we have to share the secret key with both sender and receiver. And during sharing, there could be a loss or it can be exposed to the wider audience. So that's the problem of the symmetric cryptography. Certificate authority is, or CA certification authority is the issuer of digital certificates. We are going to see what is a digital certificate, but basically digital certificates are issued by a certification authority, and these are the various CAs which are listed here. So digital certificate. So what digital certificate contains is the public key and identity of a owner. And this is signed by a certificate authority. So certificate authority guarantees that this is the owner to whom this digital certificate belongs. Okay, so let's see, this is the information about a user, Mario Rossi, and it contains name, organization, many details about the user, and it contains the public key of Mario Rossi. Now how will you trust that this key is of Mario Rossi? Anybody can create this key and share, but how can we know, how can we be sure that this is issued properly and it belongs to the exact same user? So that's where a CA comes in picture. So what the CA will do is CA will uh, certify. So what they will do is they will have a digital signature attached here. We are going to see digital signature, what exactly it means in a bit. So the CA is going to verify with the help of digital signature that this certificate, digital certificate really belongs to Mario Rossi. So that's where the CA is one which you trust. CA is already a trusted entity, and because it's signed by a CA, you trust what is being signed by the CA, and thereby you ascertain that this certificate belongs to the entity which is being mentioned in the certificate. Now hashing. So hashing is a technique which is used to protect the integrity and authenticity of a data. So basically, let's say you have some data. Okay, some data is there. So if you hash the data, you will get some output. After applying the hashing algorithm, you will get some output. It has two properties. Hashing has two major properties. First thing is it will be a fixed size output. So irrespective of the size of input, let's see here input is fox, here the red fox jumps over the blue dog. So when you apply the cryptographic hash function, the output is basically a fixed length. So this is the first property of the hash. The second property of the hash is once you have the hash of the input, from the hash of the input, you cannot generate the original text again, which means it's a one-way process. So let's read it. A hash function is a mathematical algorithm that takes an input of arbitrary size, okay, small or big size, arbitrary size, and generates a fixed size output called hash value. Okay, and this represents the original data in unique and deterministic way. Hashing is one way, meaning it is not possible to get the original data from the hash. Okay, So there are techniques by which you can get the original data. So for example, you feed lot of data, brute force basically, and you compare the digest. So let's say that I have a list of animals. So I'll start with lion, deer, dog, then finally I'll come to fox, and then I see, okay, this digest which I have is the same digest which is coming from fox, and thereby I know that the input was a fox. So that's a brute force approach of finding the input, but otherwise from the digest you cannot find the input. That's the property of a hashing function. Now let's see a digital signature. We discussed it earlier when we were discussing about the CA. So it is used to validate the authenticity and integrity of a document, okay, of any message, document, software, basically anything which is binary. Its authenticity and integrity is validated by a digital signature. So how it works? So let's say we have a document, okay, and we want to generate a signature of this document. So what we do is first we generate a hash. So hash will always be a fixed size. We saw the property of this hash earlier. So a fixed size output is generated. Now this fixed size output is signed by the private key of the signature. Okay, private key means this private key is only available to the sender, and this will generate a signature. So again, to repeat, we generate a hash. From the hash we generate the signature. Okay, now we send this document and signature over the network. So it is being sent over the network, over some ethernet network, wi-fi network, whatever, optical fiber. It is sent to the receiver. Now receiver has to verify that this document is a proper document and it is coming from a proper person, it is coming from the specific sender. How it can validate that? So first thing which it can do, this hash algorithm is basically, it's already known to both the sender and receiver that this is the hash algorithm which was used. So with the same hash algorithm, it will generate the hash of this document. Okay, and this digital this signature which it had, it should be able to decrypt the signature with the freely available public key. So it will decrypt and it will get what? It will get the hash. So if this hash is equal to this hash, meaning both the hashes match, that means that this is the document which was sent by the sender. Okay, and it has not been tempered with on the way, on the network it is not tempered with. So with the help of signature you can find out that the document which was sent is the exact document which was received, because even if one bit changes in the document, the signature will change. Okay, the hash will change, thereby these two will not match, and you know that there is a man in the middle who has changed or tempered with the data in transition. Certificate chaining. So what there is a need for an organization to generate multiple certificates, okay, for different needs. Some may be for web server, user authentication, and entity certificates. So what they do is they keep a certificate which is called as a root certificate issued by a CA. They keep the private key of that specific signature privately, and then they generate intermediate certificates, and these intermediate certificates can further sign and create new certificates, which are called end entity certificates. There could be some more intermediate certificates in between also, but this is basically the principle wherein there could be a hierarchy of certificates, and when you have to verify that this certificate is really a correct certificate, then you will go up the chain. You will see this, who has signed, this has signed, and who has signed this has signed. Do you trust the root? You will see the CA, and if the certificate authority is proper, you will know that it is a proper signed certificate. So this is basically certificates chaining, wherein a hierarchy of certificates is used and distributed across, and a software can verify the certificate is valid by going up the chain. So to see the same thing in a different view, there is a root certificate which is signed by CA, and then what you do is basically from the root certificate you generate intermediate certificates, and intermediate is signed by root CA's private key, and then this is basically the end entity certificate is signed by intermediate CA's private key. Now, what is the use of doing all this hierarchy, you may ask? So if in case I have to disable a whole set of certificates, I can just revoke the certificate. This intermediary certificate, if I revoke, all the children certificates will be revoked. Let's say that the private key of this certificate was exposed or compromised for some reason. I need not compromise, or I need not revoke all the certificates. I can revoke whatever has been compromised, and in the bigger scheme of things, other things still work. So that's the benefit of doing this certificate chaining. And the other thing which is being done is the root certificate's private key is made offline, okay, for security purpose, and thereby it grants you more security. The chaining grants you more security with respect to root certificate private key. Now let's see KeyStore. KeyStore is a Java, primarily used in Java, wherein you can keep your public key certificates and private keys. Basically, it's a repository to keep the certificate information. And key tool is a tool, command line tool, which is given or included in the JDK, which is used to put this, update this KeyStore. Okay, so basically, it will help you to create, modify, and view the contents of the KeyStore. Now let's see very quickly how the browser very cleverly, okay, utilizes the symmetric key. Okay, so there is a SSL based website. By definition, SSL is what? SSL is asymmetric, but asymmetric, we know it's computationally very intensive, and it is very slow. Because it is computationally intensive, it is very slow, and what we want to achieve is a faster web experience. So how the asymmetric is changed to symmetric in a browser, in a SSL based data transmission. So let's see. So the first step here is the browser connects to the server, okay, which is basically the website which is secured with SSL, and requests the server to identify. Okay, the server identify in the request of identification, the server will send the certificate to the browser. Okay, and as we saw earlier, the certificate will contain the public key of the server. Then what happens is the browser will verify the certificate. And how the browser will verify? Because the certificate authority details are there, it will see that it has been, the certificate is generated by the certificate authority which it trusts. If required, if it is a end entity certificate or an intermediate certificate, then it will go through the chain and arrive at the root certificate and validate that this is a certificate which it trusts. So basically it will establish trust. And this is where very important thing happens. What happens is it will generate a session key. Okay, so the browser will generate a session key, and it will encrypt the session key with what? With the public key of the server certificate. So if it encrypts it with the public key, only the server which has the private key will be able to get the session key. So this session key is sent from the browser to the server. So server, because it has the private key, it decrypts and it knows the session key. Now this session key which is there is basically with both of them. Okay, so and it is once they have the same key, both of them, then what they can do is they can use symmetric algorithm or symmetric cryptography to encrypt and decrypt data, and thereby having a faster way of encryption decryption, and having the similar amount of security. Okay, so now they are able to share, they have this session key and they are able to share the data, and which is cryptographically symmetrically cryptographically signed data. And this is a very clever approach. Okay, now let's see the similar paradigm in Nexus. So Nexus provides a repository. Okay, so a package repository. So you have a client, let's say it's a Maven. Okay, the build tool Maven, and there is a repository which is Nexus repository. So the same concept applies. So you have this SSL between these two there is a certificate which is here, and this certificate is basically used to verify that this is a genuine repository. Okay, so what happens here is the same thing, that the client will request the certificate, it will get the certificate, and then in the step 3 it has to verify that the certificate is valid. So what Maven does is it uses an alias called Nexus CA alias, and this is basically the root certificate which is installed on the key store of the client side where the Maven is running. So from the key store, it will get the root certificate and it will verify that this certificate is valid. Once it has verified that the certificate is valid, then the data transmission between the Nexus repository and with the client can happen. And this is basically, if in case you have to import a certificate to the key store, this is key tool import certificate is what you can use, and this is the details which are given for a local import. These are the major commands for the key tool, major commands which are there to update this key store: the import certificate, the delete certificate, and the list. What all certificates are there in the key store, you can do a listing. Okay, thank you very much.